Welcome to Spring LIB.
This is the answer to Chapter 12, problem number 11 from the Smith Organic Chemistry textbook. And in this problem, we are asked to first draw the structure of a compound of molecular formula C6H10 that reacts with hydrogen gas in the presence of palladium on carbon, but does not react with hydrogen gas in the presence of Lindlar catalyst. And then we're asked to follow that up by drawing the structure of a compound also of formula C6H10 that reacts with hydrogen gas in either situation. So in the presence of both palladium on carbon or in the presence of the Lindlar catalyst. And so I think the first thing that we should do, we've been given a formula C6H10. So we should go ahead and calculate the HDI for that formula. And so again, remember that's going to be 2 times the number of carbons plus 2 minus the number of hydrogens, all of that over 2. So this is going to be 2 times 6 plus 2 minus 10, all of that over 2. So that's going to be 12, 14 minus 10 is 4 over 2 equals 2. So we have an HDI of 2 here. So this tells us that we have 2 rings, 2 double bonds, or rather 2 pi bonds, or a ring and a pi bond. And so we should then think about the types of catalysts. So hydrogen gas with palladium on carbon is going to reduce an alkene or an alkyne all the way down to an alkane. Lindlar's catalyst is only going to work with an alkyne. And so that's the key here. So when we look at A, we want something that's going to react with the palladium on carbon, but not with the Lindlar catalyst. And we also need to satisfy these 2 degrees of unsaturation. And so I think that the best way to do that is probably to just draw a 6-membered ring. So that takes care of one of our degrees of unsaturation, and then to put a double bond in that ring. And so when we react this with H2 and palladium on carbon, we're just going to get cyclohexane. But when we react this with H2 and Lindlar, there's going to be no reaction. Okay, and so that's what we wanted. We wanted no reaction with the Lindlar catalyst. So then when we look at B, we want something that's going to react to both palladium on carbon and the Lindlar catalyst. And we still need to satisfy 2 degrees of unsaturation. And so the best way to do that is going to be just by using an alkyne. So 6-membered carbon chain with an alkyne in it. And so that is going to look like this. There are other solutions that you could draw as long as it's 6 carbons and 2 of them are triple bound together. That should satisfy the parameters here. And so again, when we do H2 with palladium on carbon, this is going to just become hexane. And when we do hydrogen gas with Lindlar catalyst, we're going to get the cis alkene. So remember, that's the utility of Lindlar's catalyst. It reduces an alkyne to selectively just the cis alkene. And so that's what that's going to look like from that starting material that I chose for B. And so that's the way to approach this problem. I think whenever you're given a formula and asked to do something with it and you don't really have much other information, I always think that the hydrogen deficiency index is a good place to start. And so when we do that here, that tells us a little bit more about what we need to do in terms of the structures that we're trying to draw. And then from there, it's just kind of using what we know about these catalysts to get to the final answers. And that's the answer to Chapter 12, problem number 11.